Section 2.4, One-sided limits. In this section, what we'll do is we'll extend the limit concepts to one-sided limits in the sense that, let's look at next slide. Here, what are one-sided limits? Well, let's look at how this graph behaves. So we have a function f of x, and if we take the limit of f of x as x approaches c, now this time we concentrate on all the x's that are approaching c from the right. So we use a symbol plus to mean all x's approaching c from the right, and the limit, as you can see, the y values approach letter A. Okay, now what about the limit of f of x? This time we let x approach c coming from the left. So we take a look at all these x's approaching c from the left. The y values approach b. So here we see that if we take the limit of f of x, now as x approaches c, it does not exist. But its one-sided limits exist. Okay, here's another example. And the critical value that we have to look at is at x of 0 equal to 0. So again, we try to see how the y function behaves as x approaches 0 from the right and as x approaches 0 from the left. So let's go ahead and evaluate the limit of y as x approaches 0 from the right. So as x approaches 0 from the right, all the y values are constant and it's equal to 1. Then the limit of y as x approaches 0 from the left is equal to, okay, well, here are all my x's approaching 0 from the left. Then the y values are constantly equal to -1. Now again, we ask ourselves, is the limit of y as x approaches 0, does it exist? Well, it does not, because they don't meet at a common point in the sense that their one-sided limits do not coincide at the same value of y. So the limit does not exist, but the one-sided limit does. Right, here is another example of a function which is, in fact, the function is a semicircle that has a domain from -2 to 2. And what we'll be interested would be, of course, all the interior points between -2 and 2, as well as the endpoints of our domain. So let's look at the limit of the square root of 4 minus x squared as x approaches 2 from the left. So that means I look at 2 and we find out these x values approaching 2. Their corresponding y values approach what value? Of course, that's 0. Okay, in the same way, if we let x approaches -2 coming from the right, then the y values converge at the point y equal to 0. Okay, now let's just take any particular point, say, how about this c? Right? So if we project up, what is the corresponding y value at x equal to c? Well, it's equal to, that number is the square root of 4 minus c squared. So if we want to take the limit as x approaches c coming from the left and coming from the right, they both are equal to the square root of 4 minus c squared. So for this particular example, we have that the function y equal to the square root of 4 minus x squared. It has a limit at every interior point and one-sided limits at both endpoints. Okay, let's look at then what we've been using, or how we extend the limit concept into the use of one-sided limits. Okay, a function f has a limit as x approaches c if and only if its left hand and right hand limits exist and they are equal to each other. So what does that mean? Okay, the limit of f as x approaches c is equal to L, this double-sided arrow means if and only if the limit of f as x approaches c from the left and the limit of f as x approaches c from the right are both equal to L. Both of the one-sided limits exist and they're equal to each other would mean that the limit of the function f of x exists as x approaches c. Well, let's look at this function. You have a function f of x, which is our piecewise function, and it's equal to 2 if the x's are all less than 1. And it's equal to a line 2x if the x's are greater than 1. Okay, question. What is f of 0? F of 0 is 2, right? Because it's left of 1. What is f of 0.5? Again, it's 2. F of 0.9 is 2, etc., etc. So we see that the limit of f as x approaches 1 coming from where? From the left. It's coming from the left because you see I started with 0, then 1/2, 0.9, etc. Okay, so the limit is 2. Now what about if we take f of 3? F of 3 is, so this is 1, 2, 3. So f of 3 is 6. F of 2 is 4. F of 1.5 is 3. F of 1.1 is 2.2. F of 1.01 is 2.02, etc. So we see here that the limit of f as x approaches 1 coming from the right is 2. So here we have an illustration of a function where the limit of f as x approaches 1 is 2 because we see that its one-sided limits exist because the limit of f as x approaches 1 coming from the left is equal to the limit of f as x approaches 1 coming from the right, and they are both equal to 2. So here we're saying that a limit of a function exists as x approaches, here it's 1, if and only if both the one-sided limits exist and they're equal to each other. Alright, here is another function, and it's a graph of this function is what we're going to look at. And we will examine at the value of the limit as x approaches 0, both from the right and from the left, as x approaches 1, 2, 3, and 4, and everywhere else in the interval from 0 to 4. Okay, so let's look at it, x equal to 0. The limit of f as x approaches 0 coming from the right. Okay, so here I'm approaching x coming from the right. The y values approach 1. Now, is there a limit to the left of 0? In other words, does the function approach anywhere if x approaches 0 from the left? Well, the function is not even defined here, so the limit does not exist. Now, as x approaches 1, let's take a look at the limit of f as x approaches 1. Now, here we're coming from the left. The limit is 0. The limit of f as x approaches 1 coming from the right, however, okay, so we're approaching x from the right side, and the y values are constant and it's equal to 1. So based on their one-sided limits, what can we say about the limit of f as x approaches 1? It does not exist because coming from both sides, they do not meet at a common point. There is a jump. Okay, what about at x equals 2? What is the limit of f as x approaches 2 coming from the left? Okay, if we're coming from the left, the y values are constantly approaching 1. Now what about the limit of f as x approaches 2 coming from the right? Okay, so let's see. Here, there go the little bitty x's approaching 2 from the right. Then the y values approach 1. Does it matter what the function value, what is f of 2? Well, it doesn't really matter whether it exists or it doesn't. The important thing is when we look at limits, they exist if both sides converge at a common point, like this case. So the limit of f as x approaches 2 is 1. Okay, what about at x equal to 3? Well, it's very similar. The limit of f as x approaches 3 coming from the right, or left rather, is equal to the limit of f as x approaches 3 coming from the right. Coming from the left, the y values approach 2. Coming from the right, the y values approach 2. So this means that their one-sided limits are equal to each other. So the limit of f as x approaches 3 is equal to 2. Let's continue. Okay, so let's say we already got evaluated it at x equal to 0, 1, 2, 3, and now let's look at the other endpoint. The limit of f of x, so this is at x equal to 4. As x approaches 4, now this time we want to examine as x approaches 4 coming from the left. So here my x's, they're approaching 4. And the y values approach 1. And of course, the limit of f as x approaches 4 from the right does not exist because the function is not even defined there. Okay, so this has a one-sided limit. So f has a one-sided limit at x equal to 4. Now, what about everywhere else in the interval? Let's take, say, this. Okay, does the limit exist? Of course, because if we take the limit of f as x approaches c from the left and the limit of f as x approaches c coming from the right, So here it's approaching c from the left. The y values approach somewhere, let's estimate that, right around 1.5. So as x approaches c from the left, y values approach that value of y. As x approaches c coming from the right, the y values meet at that point. So see, them having the same one-sided limit, the limit of f as x approaches c always exists and it's equal to f of c. Alright?